Hello geometry students, welcome back. Thanks for being here today. The flip grid is right up there. Go answer the question. It's good fun and I know some of you, so do it. It's good fun. You've already found the YouTube lesson. If you are here, same thing as usual. Please pause this video and try this problem in your notes and unpause it to do it. Alrighty, so we are asked what word best describes AG? Well, let's take a look at AG right here, and let's make that bigger. AG. Notice it says segment, it does not say line. The segment AG is what we call a chord. Remember, chords are segments, secants are lines. Okay, next color, let's look at CB. CB. That goes from the center of the circle to the outside of the circle. A segment that goes from the outside to the inside of the circle, to the center of the circle, we call a radius. Awesome, awesome. And now, name a tangent and a tangent segment. Now you might be asking, what is the difference? Well, this book I have found says tangent when they're talking about a line, a tangent line. So if you see tangent, it's assuming that you're thinking about a line, unless it says tangent segment or tangent ray. So we're going to look for a line that is tangent. The only option we have, it looks like, is this line right here. Now we could name it DB, we could name it DE. I'm gonna do DE. I like that. So a tangent would be DE, and we need arrows, the line. And now a tangent segment. Well, we could just do DE segment, and no arrows on the top. Awesome. So now we're just talking about this part of the. Yeah, that works. You could have picked DB, could have picked BE, could have picked a lot of things. Don't matter. Don't matter. Alrighty, thanks for doing that with me. Now let's move on to what we have for today. Today we're continuing 10.1. This is the second half. Our learning target says oops, that should say I know. I know theorems about tangents, and our success criteria is I can use properties of tangents to solve problems. So let's jump right into it and figure out what are those theorems about tangents. What are the properties? Well, please pause this video and write down these theorems because they are important. Unpause them so that we can chat. So our first theorem is a tangent line to circle theorem, and what it says is that in a plane, so all of this is happening in the same plane, because if you skew things, it messes things up. So we're just assuming that we're on the same flat sheet of paper for all of these figures. So in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint. So, and let's even zoom in on here a little bit. So this point right here, if this ain't a 90-degree angle, this is not a tangent. But if this is a 90-degree angle, then this is a tangent. And it works the other way too. If this is a tangent, then I have a 90-degree angle here. That's what that theorem says. Alright, the next one, the external tangent congruence theorem, the fancy name for a simple thing. Tangent segments from a common external endpoint, or an external point, are congruent. Tangent segments from a common external point, so this external point is S. So these tangent segments are congruent. That's all that means, is that you have, if this is a tangent segment and this is a tangent segment, they have to be equal. have to be congruent, which means that their lengths are equal. That's it. And today we are going to do 2 examples, one of each theorem, and then you'll have homework. So let's get on with it. Example 4, finding the radius of a circle. In the diagram, point B is a point of tangency. Ahaha. Okay. Find the radius R of the circle C. Okay. Well, if B is a point of tangency, that makes AB a tangent segment, and our first theorem said that a line is tangent to a circle if and only if the line is perpendicular to a radius at its endpoint on the circle. So, if this really is a tangent segment, that means that this must be a right angle. Okay. Hey! That makes this a right triangle! If we have a right triangle, we can use the Pythagorean theorem. Oh my sweet biscuits. Okay, let's not use, there's already a... Let's see, we'll call this A, this B, and this C. Doesn't matter which one A and B are, but what does matter is that C is opposite the right angle. And now we have A squared plus B squared equals C squared. A is R squared. B is 80 squared. And C is a little bit weird because it's the 50 chunk right here and it's the R chunk right here. So C is actually 50 plus R squared. And remember, I need those parentheses because if I just write 50 plus R squared, what you're doing is you're squaring the R, but you're not squaring the 50. Remember, for this Pythagorean theorem to work, I need to square the entirety of C. I need to square all of C, not just part of it. Alrighty. So hopefully you remember how to do this from algebra last year. Hopefully. If you don't, I will show you now. So R squared plus, oh boy, 80 squared is 6,400. So the way we do this is I'm going to square 50. 50 squared, 2,500. And now I'm going to take 2 times 50 times R. And then I take the last one, R squared. If you don't remember that, this is the sum of squares pattern, and it goes like this. If, ooh, a loud email notification. If you are confused about this part right here, getting from here to here, you should go watch the geometry video that I made from 2 days ago. In fact, I'll put a link. I'll put a link in this slide to that video for you. Okay. Alright, and now we just need to solve for R. So, woo, I'm gonna get all my R's on one side. So let's see if we minus R squared from both sides. It cancels here. Oh, and it cancels here. That's nice. That's nice. Okay. So now let's just continue. Now we'll put our numbers on this side, I guess. So minus 2,500 from both sides. And now we have, what's 6,400 minus 2,500 is 3,900, which equals 100R. Did the 2 times 50 times R. So now let's divide both sides by 100. And we get that 39 equals R. Bada bing, bada boom. Again, if you have questions about this part, there will be a link to that algebra video. in the description. In the description of this video. Alrighty. Moving on. Well, let's make sure that we got it right. Yes. R is 39. Wonderful. Fantastic. Oh, 39 feet. We forgot our units. We forgot our units. Feet. Perfect. Okay. Moving on to our next theorem, second example. Then you will have your homework. Alright, RS, do a different color. RS is tangent. Okay, RS is tangent at point S. And RT is tangent at point T. Okay, find the value of x. Oh, well, hey, we knew from our second theorem that any two tangents with a common point, external point, means that these are the same. So 3x plus 4 has to be the same as 28. Now we're just going to solve for x. And there you have it. We found the value of x. Not too bad, is it? Not too bad. Alright, let's check and make sure that we were right. Yup, external tangent congruence theorem. That was our theorem number 2 from today. And we also got 8 for x. So yay. Awesome. That is all I have for you today. If you have questions, be sure to tune into my live stream every weekday from 12 to 2 p.m. It's a fun time. You should be there. Especially if you have questions. Alright, your homework for today. 4 questions like the first example. 4 questions like the next example. Yes, indeed. Yes, indeed. Alright, and your launch for today comes from Amy Poehler. I like Amy Poehler. She says, limit your always and your never. So, if you don't understand what that means, it means try not to say always or never, because those are very absolute statements. I always brush my teeth every morning. Well, is there ever a morning that you forget? Like, you always forget to turn in your homework. Well, wait. What if you turn in one homework, that makes that statement untrue? So, yeah, and same thing. You never listen to me when I talk. Like, hang on. If there's one time they listen to you when you talked, that statement is now invalid. So, try not to use the word always and never, because it's very absolute. And there are not a ton of absolutes in life. So, be more understanding of each other. Limit your always. That's my launch for you. Take it with you as you go throughout the day. I hope you have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.